All right, good evening. Welcome back to Differential Equations here. So today we are going to be talking about section 2.6, which is Euler's method. All right, so a couple of things to start with first. Okay, let's see. So you remember, right, that y prime was equal to f prime of x, which was f of x plus h minus f of x all over h, right? That definition we made you memorize in Calc 1. He said, but why? Well, here's one of the reasons. We always go back to this. Okay, we're going to solve for f of x plus h here. Okay, so we're going to say f of x plus h minus f of x is equal to h times y tick. And then add f of x on both sides and get f of x plus h equals h times y tick plus f of x. Okay, now what we're going to do here is we're going to say that f of x plus h, hold on a second. All right, back to this. Okay, we were going to say this is going to be my new y value, right? Because we took our x and added a little h to it. Our f of x, that's our old y value. Okay, our h, that's our step value. Okay, back in the day, h used to be delta x. Okay, but we're just going to, that's going to call our step value. And y prime is our slope, just like you'd expect. Okay, so our formula for Euler's method is that our new y value is equal to h times your f of, h times your, oops, don't say it, our y prime value, right, our slope, our step of a slope, okay, plus our y old value. Okay. Okay, and what we're doing is we're just going through x's, right? We're just going to step our x. Okay, our new x, by the way, our new x is going to be our x old plus h. Okay, so some things they have to give you. Okay, in the book right now, they're going to give you the problem. They're going to give you, y prime is equal to f of x, 8xy. This is our standard form for using Euler's method. Okay, y prime equals some function of x and y in it. They're going to give you, okay, so given, they have to give you an h value. Okay, later on, you're on your own to discern what your h value is. Make it something small, but not too small. Okay, and they have to give you an initial condition. So f or y of x naught is equal to y naught. Okay, some initial condition. So what we're going to do here, okay, we'll do a little example. All right, actually, let me not go with the example just yet. Let me just draw you a generic picture of what's going on. Okay, so here's our x naught, y naught, our initial condition. And what we're going to do is we're going to generate a slope, right? Because we have y prime is equal to f of x plus y. We're going to generate a slope, and we are going to step in that direction. So here is your x0. Here is your x0 plus h, or x1. Okay, so here's our x0. All right, and then from this point, again, right, we're going to reevaluate. We're going to say, oh, well, great, we've got two new x points, two x's and y's points. Let's put them in here and figure out a new slope. So maybe you get a new slope. Okay, and you're going to follow that one unit down, okay? So here is my x1 is equal to, or x2 rather, is equal to x1 plus h. All right, so we'll go ahead and have that. So here's my value there, okay? And then maybe one more, right? We'll have x3 is equal to x2 plus h, okay? One step, and we'll have our step, okay? And then slowly but surely, we are going to fill in, right, our our values. So the goal here, right, what they're going to ask you to do is they're going to say y of some n is equal to what? Okay, that's our question, is get this thing. Sometimes the question is to generate this curve, okay? But often the way that the book phrases it is that they want to know a specific value at the end here. Okay, we'll do both. So the way I used to think about this, the way I still think about this, is if you've ever walked a dog without a leash, okay? You know, you're not supposed to do that, but, you know. Back when I was a child, you know, you weren't supposed to do it either, but there weren't any cameras to prove it. So you would start, right, and your dog would bound off to whatever bush, tree, lamppost, or whatever they thought was interesting. But after they bounded off, they would kind of check back. They would look at you. Okay, if you had a reasonably well-behaved dog, they'd look at you and see, which direction are you headed? Okay, I can run in that direction. And then when the dog is here, it's kind of looking at you. You're walking slowly forward, and it's going to be looking and saying, well, what direction are you headed in? Great, you turned a little bit. We're gonna move. We're gonna go in that direction now. Okay, and then again, it'll find whatever nearest bush, tree, lamppost, whatever that's interesting, and it'll turn back and look at you, and you say, okay, well, you're walking in that direction now, and it'll bound forward and it'll lead past you and it'll go to a different part, right? So it's taking a step and then checking back to see which direction you're facing, and then it's changing its next direction based off of which direction you are. Okay, again, if you have a reasonably well-behaved dog. Okay, so that's kind of what we're doing. Okay, so you have a position. We're going to bound in a particular slope, a particular direction. Once we reevaluate, we get to that point, we're going to check our slope again, and we're going to bound off in the position, the slope, the direction of the slope says for the next one, and so forth and so forth and so forth. Okay, so that's what we're doing here. All right, now let's go ahead and do an example. Now, what I'm going to do for our example here, okay, is I'm going to do a little bit of it by hand, but then I'm going to quickly turn to Excel because I'm not a good, doing this by hand is not a fun thing. And I would recommend, like, know enough Excel to be able to put this together as well. Okay, we're going to talk about more complicated things and more, more useful differential equation solvers later, but don't write this down yet. Okay, but we'll get there. Okay, this is the first idea of how to solve this. All right. So here we're going to have y prime f of x. Okay, y prime is equal to, and let's do x plus 2 over y. We'll say h is equal to 0.2, or fifth. Okay, and we'll know that y of 0, y of 0 is equal to, we'll say 1. Okay, so we're going to build a little chart here. Okay, now I'll put this down. So we have x and a y. Now, some people, they have learned this earlier, and if you have a slightly different chart, that's fine. They're all equivalent. Okay, and we'll say here's our y prime is equal to, right, x plus 2 over y. Our h is always going to be the same. Okay, h is 0.2 no matter what. Some people like to include it, some people don't. It doesn't really matter. And then we're going to take our y prime times h. Right? Remember, back at the top here, right, we have our y new is equal to h times y prime plus y old. Okay. So we'll evaluate our x plus 2 over y here. I should probably make a little bit more room. Okay, it's coming back. I'm just going to move it over a little bit, okay, because we're going to need some room. Okay, put that here. We'll say h, and again, you don't have to have the 0.2. Okay, but they're all 0.2. And then h times y tick. We probably need a thing here. And then we'll say our y new is equal to y old plus h times y tick. All right. So there's going to be a lot of arithmetic, and we'll, like I said, I'll do a couple on paper, and then we'll quickly move to something else, okay? Do that. All right. So what's our beginning position? X was 0, Y was 1. Before we start off, what's our next, when we advance by 1, we go, well, what's our next X? Our X is whatever our previous one was, plus our H. So it's going to be 0.2, and then 0.4, and 0.6, okay? We want to know what's Y of 1 equal. Okay, that's our question. So back to the beginning, right? So we have Y prime, right, is equal to 0, 0, plus 2 over 1 is equal to 2. Okay, H times 2, right? So 0.2, 0.4, okay. 0.2 times 2, right? 0.4. And our Y new is equal to, right, is, so Y is equal to 1 plus 0.4 is equal to 1.4. Okay, that's probably the end of the nice, easy numbers. Okay, so notice whatever you have here turns into this one. All right, next, Y prime, right, that's equal to 0, or X. Okay, let's put that bar back in. So our X, which is 0.2 plus 2, divided by, what's our Y? Y is now 1.4. See, this now gets delightful. Okay, so we have 2.2 on the top, right? 2.2 on the top, divided by 1.4 on the bottom. Okay, and then we're going to multiply this. So this was 1.5714. They'll tell you as well, they go to so many decimal places. I'm going to go to 4 for the sake of argument, but they'll probably tell you. Okay, I think for most of the time I have people go to 6, but this is fine. So we're going to say 0.2 times our previous answer. And this is 0.3143. 0.3143. Okay, to 4 decimal places. All right, so it's 0.2 times this guy here. And now we're going to say, well, what's our old Y? Our old Y was 1.4 plus 0.3143. And what are we ending up with here? We end up with 1.4 plus 0.3143. 3143. And we ended up with 1.7143. 143. So my new X, right, is 0.2 more. So this is my new Y is 1.7143. Okay, Y tick, right, Y prime, our slope, was equal to 0.4. That's my X, plus 2 divided by, it's a 4, 1.7143. See, I told you this was going to get to be fun. So let's see here. Let's go ahead and take a look at 0.4 plus 2, 2.4, right, divided by 1.7143 equals. Okay, and this was 1.39. Actually, it's like 1. If I round to the third decimal place, that's going to bump all this up. It's going to be 1.40 again, isn't it? Oops, I didn't want to do that. I just wanted to erase. So 1.40. All right, times 0.2, because this is, H is always 0.2. Well, not always, but in this problem. Okay, so we have 1.4 times 0.2. Okay, we got 0.28. All right, and then my Y new is equal to 1.7143, that's this beast right here, plus 0.28. Okay, so what is that going to give us? That's going to be 1.7143 plus 0.28 equals Okay, and this was 1.9943, and that's going to go into the next spot. So we're going to have a 0.8, okay, 1.9943. It's my y value, my y prime, right? That's 0.8 plus 2, okay, divided by what? 1.9943. This is still 0.2. Okay, so what is this going to be? I'm sure this is going to be equally delightful. So we have 0.8 plus 2, okay, 2.8, divided by 1.9943 equals, and this was what, 1.404, 1.4040. Okay, times the 0.2, right, so times 0.2, and we get 2.8 or 0.2808. All right, and then my new y, right, is going to be 0.2808 plus 1.9943. See how fun this is? Okay, plus 1, oops, I don't want any of that, plus 1.9943. We ended up with 2.275, 2.2751. All right. Now, here's something that you always have to remember, okay? It means you get to do less work, so you're going to remember it. 0.8 plus 0.2 is 1, okay? This is 2.2751. Hey, what's y of, right? What's y of 1? 2.2751, isn't it? We're done. We don't have to do any more. So once you got to that point, you're finished. Okay, so let's talk a little bit more about this example. So we had y prime is equal to x plus 2 over y, right? And y of 0 is equal to 1. We could just solve this. We didn't need to go through all of this, right? This is y dy is equal to x plus 2 dx. I mean, my favorite kind. This is separable. We should be able to do this, no problem. Integral x plus 2 dx. So what do we have? We have 1/2 y squared, right, is equal to x squared plus 2x plus c, right? And we could do this at different times. Why don't we go ahead and say something like y squared equals to x squared plus 4x plus c. So shouldn't that be 2c? Like 2 times c is c. We don't have to worry about that. And then y is equal to plus or minus the square root x squared plus 4x plus c. Okay, and since we're not like dealing with c's in different places, right, we don't have to track which one is which, so we just have it c. Okay, what did we know about this? We knew that y of 0 is equal to 1, didn't we? So we have 1 is equal to plus or minus square root, right? It's going to be the positive because, right, we want the positive side. 0 plus 4 times 0 plus c. So we get the square root of c is equal to 1. I think we could safely assume that c is equal to 1. So here we have it. We have y is equal to the square root x squared plus 4x plus 1. And what do we want to know? We wanted to know what y of 1 was, right? So what's y of 1? We have y is equal to the square root, 1 squared plus 4 times 1 plus 1. Okay, 1 plus 4 plus 1. And y is equal to the square root of 6, which is to 4 decimal places. What is this? Okay, yeah, this is the square root of 6. 2.449. We get another one. 2.4495. Okay. So what we're going to do next is we're just going to compare error. Okay, we're going to say our percent error, right? This is y actual minus y experimental. The numerical one is the experimental. The actual one is the one we solved. Divided by y actual in the absolute values times 100. Okay, so actual minus experimental divided by actual. It doesn't really matter which order you put these in because we're getting the absolute values. Don't matter. Okay, actual 2.4495 minus, okay, 2.2751. 2.2751 divided by the actual 2.4495. Okay, times 100. So what are we going to have here? That's going to be 2.4495 minus 2.2751 equals divided by 2.4495. Okay, and then times 100, and we end up with percent error equals 7.11%. Okay, 7.12%. Fair enough. Okay, that's a lot to write down. Why don't we not do that ever again? Okay. I mean, doing it once by hand to see it all in its gory detail is probably good, just for the sake of having it. But you know, I'm gonna go. We're gonna use more advanced methods in just a little bit. But for now, you know, this is sufficient. X, Y. Let's go with Y prime. Oops. Let's get rid of that. Okay. We're gonna have our H equals 0.2. Okay, so let's go ahead and this over here. Okay. Okay, we'll move this over a little bit. Control X, Control V. We'll say H times, actually let's do it this way. Let's say that just Y new equals H times Y tick plus Y old. Okay. So here we have X starts at 0, right? And then we go up by 0.2. I'm going to go ahead and say fill series columns. There's a dozen different ways to do this, so you can do it however you'd like. It's fine. Stop value of 1. Okay. My Y value, I have a start, right? And this is going to be, right? It's going to be X plus 2. So we want X, put the cell in there, plus 2, that doesn't change, divided by, put the cell in for the Y. Okay. That should be good. So that's my Y tick, right? And then we're going to have plus 0.2 times this previous cell. Okay. And then our Y old. Oh, I didn't do it that. I just did the whole thing. Okay. So let's keep going. Okay, that's F2 to edit a file, okay, or edit a cell. So that's H times Y tick plus our old one. That's our old one. Okay. So 1.4. Are we kind of in the ballpark for what we started with? Right, when I first started doing this, we ended up something like this, didn't we? Okay. So what we're going to do here is I'm going to say, oh, this is plus this thing. Okay. Let's do one more, and then we'll cut and paste and not have to do any of this. So Y prime, right? We can just do this one and this. We can cut and paste that. Okay. So notice if I press F2, right, I can see what's being added together. Okay. So X plus 2 divided by Y. Excellent. and then we'll go ahead and Control C and Control V that one. And again, we have our original y plus 0.2 times our y tick. Okay, and again, what do we get? 1.714. How did we do? 1.714. Okay, great. So now what I'm going to do is I'm just going to copy all of this and select where I want to paste it. And ta-da, look at that. So we can see this one is the same as that. If you go through and press F2 here, you can see it's the same. This is the same one. It's the same one. It's the same one. Okay. So there we go. Did I get the? I don't think I got the right answer. We just screwed something. I would trust the Excel's arithmetic far better than I would trust mine. Okay. 2.275. What do we end up with? I probably didn't multiply by a 0.2 in here, and something weird happened. Okay. 0.99. Something in here didn't quite work out too well. 2.25. I may have missed, oh, you know what? I probably missed by 0.6. I probably skipped one. Okay, my bad. All right, this is why we also have Excel, is to do this. Okay, so my apologies that I messed this up, and my percent error is going to be a bit off than what I said it was. But the idea of being able to follow this algorithm, follow this method, is what we're looking for. Okay. The other thing I want to do is let's go ahead and do that. Let's go ahead and make our y actual. Okay. And that's going to be plus a square root of my x squared, right? Plus 4 times, again, that x. So we're just going to copy that. Okay. Plus 1, right? And that is our actual values here. Okay. And again, we'll go ahead and double check. Square root of x squared plus 4 times x plus 1, we're good. Okay. So what do I want to do now? Okay. Sometimes the interest is getting these two numbers. Okay. And our h of 0.2, that's pretty big. Okay. So we could do a new thing. We could say, oops, I want to do plus, nope, come on, plus this piece minus that piece divided by this piece, okay, plus abs this thing, and then plus this thing times 100, which is a bit bigger than the error that I thought I had, so it's almost 12% error, so that's pretty bad. But like I said, my h is horrific. Okay, my h is extremely large. So the other thing that we're going to do here is I'm going to go ahead and make a table or make a chart. Okay, so what do I want? I want a graph. Insert. I want a graph. I usually use scatter plot. You don't have to, but scatter's usually pretty good for science and math stuff. Okay, and what I'm going to do here is chart title. We're going to select some data. I'm going to remove, I don't know what they selected, but I'm just going to remove it. We're going to add. Okay, so this is Euler's. Equals Euler's. And our x value, we're going to go ahead and say, here's our x's. Okay. And then for Euler's method, right, here are our y's. So these guys, these are our y's. All right. And that's going to be our value. Go ahead, let's add another one. So we're going to add another. So we're going to say this is our actual. Okay, and again, our x's are going to be these guys, right? That's what we still have. And our y values, that's going to be this piece. All right, okay. So there we go. We are off from the beginning. Oh, I think I messed up with my y's. Okay, I wanted my y's to be here. Let's go ahead and edit this one. So Euler's, let's edit. So my y values are actually these guys. Oh, that looks so much better. Okay, the other one looked a bit weird. Okay, so the blue one, that's our Euler's, our red, that's the or orange, that's the actual one. So you can see we're not actually too far apart with all of these. Okay, so that's what we have for our solutions. Okay, I'm actually like a little bit tempted. Like, did I mess this up too? What is this? This is, it did mess it up. Look at this. Should be G. That's the next one. That's Y of 1.2. I want this one. 2% error. There we go. I'm happier with that. Okay. So yeah. So they should be close, okay, because Euler's is pretty good, but it can get you into trouble if you let your H's get to be a little bit too big. Okay, so the way of keeping everything under control is to keep your H small. Be careful about that though, because if you make them too small, your runtime gets to be bigger and bigger and bigger. And I know that nowadays, right, we have computers that go incredibly fast, make billions of computations per second. But you know, if the y's, if this function gets to be difficult, it could take longer. And if you make your x's like times 10 to the negative eighth or something, it gets to be you can take a long time to solve these things. So just want to be careful about that. It's still going to be polynomial time. It's okay, but just to be careful with that. Let's see. Do we want to do one more? Maybe. I think we could try. Okay, we could try for one more. Let's start here. Okay. So is the value I wanted. There we go. Beautiful. Nice looking problem, if I do say so myself. So let's do the y prime is equal to xy plus the square root of y. Okay, and we'll say y of 0 is equal to a half. Okay, so I'm going to go ahead and solve this one analytically first, and then we'll jump into Euler's method. So you could look at this and say this is y prime minus xy is equal to y 1/2. You say, aha, look at that, it's Bernoulli's. We could solve this. So we're going to set u is equal to y to the 1 minus 1/2, right? That's our Bernoulli's, is u is equal to y to the 1 minus n is half. Okay, so we have u is equal to y to the 1/2. Okay, so u is equal to the square root of y. U squared is equal to y. Dy is equal to 2u du, right? So let's go with this. So here we have it, du. So we have 2u du minus x. What's y? Y is u squared. Is equal to y to the 1/2 power. That's u, right? And in order to make this first order linear, we divide everybody by 2u, 2u, 2u. Okay, so we have du minus 1/2 x, u squared over u is u, right? And that is equal to 1/2. Beautiful. So let's go ahead and make our integration factor, right? Our integration factor is e to the negative 1/2 x, right? Because that's the value here. That's our p of x, which is equal to e to the negative 1/4 x squared. Right, remember what happened to the c was it cancels out when we get finished. So here's our integration factor. Okay, So we're going to multiply this through. So we're going to say this is e to the negative 1/4 x squared times u, du rather, minus 1/2 x e to the negative 1/4 x squared. I hope you could see if I took this derivative, we'd end up with the chain rule. This is what we'd have. Okay, and this is just u. Okay, and this is equal to 1/2 e to the negative 1/4 x squared. Okay, so this is clearly the derivative of e to the negative 1/4 x squared times u, and that's equal to 1/2 e to the negative 1/4 x squared. Now, when I want to integrate this thing, okay, when I want to go off and integrate this, there's a problem, isn't there? Like, this one is fine. I mean, this is, e to the negative 1/4 x squared times u is equal to y to the 1/2, right? So this is e to the negative 1/4 x squared times y to the 1/2 is equal to the integral from negative infinity to x of 1/2 e to the negative 1/4 t squared dt, right? Because this is not a form we can integrate. You're screwed. So unless I have something, because first off, right, I got to take the square in order to get it here. There's a plus c once I do integrate this. All right, that's delightful. And then when I'm done, right, I've still got to multiply this. So this is y is equal to e to the positive 1/4 x squared times the integral of negative infinity up to x negative, or 1/2 e to the negative 1/4 t. See how delightful this looks? dt squared. I can't wait to try to solve that. So yeah, the analytic part on this one, like, no, we're not doing it. Okay. And do you see how easy of a function we started with to get something that was like the only way you could solve it is numerical? Okay. So it doesn't take much just to nudge this thing off into, oh, I can't do it. Not analytically. So instead, right, we're going to go back up and we're going to say, well, let's get something done here. Okay. So that's so we can see it. So let's go ahead. Let's go with h is equal to 0.05. Okay. 0.05. That's what your book often does. And again, you're using Excel for this, okay? Or if you are better at MATLAB and you have something written, go right ahead and use that. Okay, I'm sure Python has an Euler's method or subroutine. That's fine. Okay, our y prime, right? What was y prime? That was equal to xy plus square root of y. And we had y of 0 was equal to what? Okay, back to our beginning thing here. Y of 0 was 1/2. Okay, xy plus, so let's double check that. Plus, and y of 0 is equal to 1/2. Okay, so let's go ahead. We have our x, we have our y. We have our y prime is equal to xy plus square root of y. Okay. Let's go with y nu, right, is equal to h times y tick, okay, plus y old. Okay, our y, this is y old here. Okay, so we're going to start off with 0. It's 0.05. Okay, 2 nickels, right? That's a nickel. So then we have a dime. We're going to have 15 cents and so forth. Okay, what did they ask us for? Did I write that down? They want to know what y of a half is. Okay, sorry about that. They want to know they want to know what y of 0.5 is. Okay, again, has to be given, otherwise we're not, you don't know where to stop. Okay, and that's not good. Okay, and we want to know what is y of 0.5. So here we go. We're going to go down here and we're going to say we need to series. Okay, get the columns, otherwise it'll go all the way across and it'll be terrible. Our step value is 0.05, so we're counting up by nickels, and we are stopping when we get to 50 cents. Okay, that's not too many steps, that's not too bad. Our y old, what are we starting with? Right, y of 0 is 0.5. Okay, and then our y tick, right, that's equal to, we want plus x times y plus square root of our y. Yeah, because we're going to get 0 plus a half, and the square root of half is like 0.707. That's fine. And then what we're going to say is our new is going to be plus 0.05. I mean, we could do it this way, right? We could say plus this thing, but what we're going to do is we're going to hit F4 after it, and that's going to change the dollar signs, which is going to say now it's constant. Okay, so a little Excel trick there for you, times our y tick plus our y old. All right, oops, what didn't you like? What didn't you like? Oh, because it's h equals, oh, yeah, that's not going to work. It doesn't understand it's a string. So we could just say 0.05. 0.05 times, there we go. All right, that's better. All right, and again, you could break these up into smaller pieces, and that's fine. Okay, so we're going to do plus, this is my new y. Okay, and unfortunately, I can't even verify this with this. Okay, we're just going to hit Control C, Control V, and that's our function right here. I can't even verify it for us. Okay, we just take this one on faith. See if I was smart. You know what? Let's go ahead. Let's change this. Let's just say this is 0.05. Okay, and we'll say here's our h. You know why I want to do this is because your book has you do it for h is equal to 0.05, and then other things. Don't forget to put the F4. Don't forget to put the dollar signs there. F4 will do it for you automatically. If you press it multiple times, it'll change how that works. Okay, but and then we'll just go ahead and say Control C, Control V. Okay, so now it's all right. It's always B2, because your book is going to have you go, oh, what about 0.1? Okay, and then here, oh, I should have changed it for this one too. Okay, this is going to be, yeah, I need to change this one. So 0.1, 0.2, 0.3, 0.4, 0.5, and then at that point we're done here. Okay, so 6.7, 0.8, 0.9, and 1. Okay, so they wanted us to compare, right, for 0.5 when h was 0.1, and y of 0.5 when h was 0.05. So if you do it a little bit more cleverly than this, you only have to change this guy out here. Make sure you change your x's, and then it'll propagate through, and you won't have to do as much of the busy work. Okay, so I just wanted to show us this again. I don't have anything to compare it to in this case, right? So we're going to go insert, hit your, don't do a pie chart, do a scatter plot, and then I'm going to go ahead and say, I just clicked on the graph. Okay, select my data, and then add, and then we'll say series name, Euler's x values. We're going to go ahead and copy down our x values. Y values, we're going to copy down our y values. It's y old because those are the corresponding ones. And we'll just say, okay, boom, there it is, you're done. Okay, so just to show you that, I think that's plenty. We'll talk about some more advanced methods next time and how to do this in MATLAB rather than in Excel. Okay, so I'm going to leave it there, and I'll be back with another recording. All right, thank you.